So in this video, I'm going to teach you how to find the correlation and make a scatter plot for data in a linear regression. And in order to do this, I'm using a TI-84, but you can also use a TI-83, a TI-Inspire, or other types of calculators to do this. We normally use technology to make these things. And so the example here says to draw a scatter plot and describe the relationship between the variables. And when we describe their relationship, we're talking about their correlation. So it says a student conducts a study to determine whether there is a linear relationship between a student's height in inches and their pulse rate. The data is shown below. And so to put this into a calculator, we need to get it into a list first. So to get to our list, we're going to press the stat key. And we have this list menu, and we're going to go to edit. And in edit, we're going to go ahead and type in these values. And so to type these values in, if you already have numbers sitting in your list, to clear those numbers out, you're going to highlight the list. And you should be able to see all those numbers in the list down here like this. To clear them out, we press the clear key. When you press clear, the numbers will erase out of that bottom line. Press enter, and it clears the entire list. Never press the delete key on that. If you press delete, such as if I highlight the list and press delete, notice I've lost the L2 list. To get it back, I'm going to press stat, and that's time I'm going to press 5, setup editor. I want to set the editor up. Press enter, it'll say done. Go back to stat and look at your actual list again now. So go stat and edit, look at the list. L2 came back. So again, to erase L2 or to clear L2, we highlight it, press clear, and then press enter. So now we're going to go back and type in L1, we'll type in the explanatory variable height here. So we'll type those values in. And then in L2, we're going to type in our response variable pulse rates. Notice that for each height, there is a corresponding pulse rate here. So the first thing we want to do is we want to graph this using a scatter plot. To graph with the scatter plot, you see where it says y equals here. Above that are your stat plots. You need to turn the stat plot on for scatter plots. So we're going to press second. It's in blue, so we'll go second, y equals. We'll do at the first plot where it says flashing on and off. We want to make sure it says on. Plot 1 is on. The types, you have a scatter plot, a time series line plot, a histogram, a box and whiskers with outliers, a box and whisker with no outliers, and then you have a quantile plot. We want to do the first plot, which is a scatter plot. We want to make sure X list says L1, Y list says L2, and once this is done, we'll press graph. Notice when I press graph, nothing shows up on my screen, and that's because our screen is set, our view is set for a standard graph. We want to do the stat graph. So to do that, we'll press the zoom key over here, zoom, and we'll go to zoom stat, which is number 9. So when you press zoom stat, it goes ahead and graphs it for us. And we can see now that this data is pretty spread out. If you're trying to get a general trend of it, it's very hard to look at and get that. But it looks like it may or may not be, it may be positive if you try to draw a line through it. So to further help us with this then, because looking at this doesn't help a whole lot, what we're going to do next is we're going to look at the actual correlation. And remember, our correlation tells us two things. It tells us the strength of the correlation, which is a number between -1 and +1, and the direction of the correlation, which is going to either be positive or negative based on the slope. So to look at that correlation, what we're going to press is your stat key again, and we'll go to calc this time. And what you want to do is we want to do linear regression. Linear regression is going to show us our correlations. So we want to do linear regression number 4, ax plus b. And regression is going to ask you for an x list and a y list, depending on what calculator you have. If you have a TI-83, you'll just say linreg on your screen, and you'll just press enter because you'll have it in L1 and L2. So we're going to set this to L1. So to get L1, you're going to press second. And notice above the 1 key, you have an L1. So I'll press second, 1 to bring up L1. And y list is L2, so I'll press second. Above the 2 key, you have your L2. Leave the frequency here. You don't need to store the regression equation yet. And we'll go to calculate. When you do this, it'll give you A and B. What you have to do now is you have to look at the actual R. We're actually interested in the value of R and R squared. To find those values, R and R squared, we need to actually turn our diagnostic on. So to turn the diagnostic on, you press second, 0, which brings you up to your catalog. And you want to scroll all the way down to the D's. So you want to get all the way down to the D's here. And you want to find diagnostic on. So once we get to diagnostic on, which is here, we'll press enter and enter again, and it'll say done. Now with our diagnostic on, we're going to press stat again and do linear regression. So we arrow with a calc, arrow all the way down to number 4, lin reg, ax plus b, press enter. Make sure x list is L1, y list is L2, and go all the way down to calculate. Once you press enter here, now you can see a and b are still the same as what they gave us earlier, but we have now r squared and r. If you look at your r value, it is a negative 0.146, which when we try to measure that, the strength is weak. It's in between 0 and 0.3. The direction is negative. What this really says in terms of correlation in that is as the height increases, it looks like our pulse rates tend to decrease. So as heights increase, as x increases, the y variable either increases or decreases based on the sign of the correlation. Since it's negative, my variable is going to decrease. It's going to decrease. That's what this is saying. Now, that's a very weak correlation, so it really can't say that much, but we can say that based off the correlation.